morning students, how are you all?
Fine.
All right. Okay. So, do you remember what we have discussed in the previous session?
Yes.
Yes? All right, wonderful. We have talked about evaporation, condensation, and how dew and fog are formed due to condensation. Yes? A quick recap before moving on. Now, how did we define evaporation? It is the phase change from liquid to gas, which can happen at any temperature. And this phase change from liquid to gas happens at the surface of the liquid. And hence we said evaporation is a surface phenomenon. Correct? And also it is a cooling process. Why? Because energy is taken out by the escaping molecules. Escaping molecules gain energy from the other molecules inside the liquid and they come out of the liquid. So, energy is being taken out from the liquid and hence it is a cooling process. Correct? And then we discussed about condensation. Again, this is the phase change from gas to liquid. From gaseous phase to liquid phase, the change of phase takes place. That is called condensation. Right? And condensation is a warming process because the energy from the vapor particles is being supplied. Correct? And hence it is the warming process. Now, as a result of condensation, during winter especially, we see dew and fog being formed because the water vapor particles present in the atmosphere, what happens when they collide with the cold surfaces, they turn into water droplets and dew is formed, right? And if temperature falls even further, these water vapor particles will change into water droplets and these water droplets keep floating in the air. They get settled on the dust particles or the other air particles and a thick mist is formed and that we call as fog. Okay. Any questions before moving on? No? Alright. So, having said that, let's move on to the next topic of the session. Now, this is going to be an interesting topic. Now, let us understand what exactly boiling is and how it differs from evaporation. Okay. So, to understand this, let's do a little experiment. Let's take a beaker filled with water and we'll start heating the water. Now take the temperature readings of the water as you heat them for every 2 minutes. Alright, we'll take the temperature readings for every 2 minutes. Now we observe that the temperature of the water keeps raising at a constant rate. Now, once the temperature reaches 100 degrees Celsius, the rise in the temperature stops there. Even though we continue to supply heat energy, we don't see any substantial amount of temperature rise in the water. And one more interesting thing happens once the temperature of the water reaches 100 degrees Celsius. What is that? You will start seeing a little bubbling in the water, right? And you see vapor coming out of the water. So, at 100 degrees Celsius, the water starts converting into gaseous phase. So, this process is called as boiling. So, we can define boiling as the process wherein the gaseous phase is being, the liquid phase is being changed into the gaseous phase, that too at a constant temperature. Alright, so this is what boiling is. Let us write down the definition clearly. So this is the definition of boiling, which is a process in which the phase change happens from liquid phase to the gaseous phase, and that too this happens at a constant temperature and at any given pressure is called as boiling. So in case of our experiment here, where we have used water and we started measuring the temperature of water for every 2 minutes, what happens once the temperature of water reaches 100 degrees Celsius, water starts boiling. So this is that constant temperature wherein the process starts. The process of phase change from liquid to gas starts, and hence this is boiling. Now, this constant temperature at which this phase change occurs is called as the boiling point. So this boiling point varies from substance to substance. Okay, so that constant temperature is nothing but the boiling point. Now we have seen that even though we continue to supply heat energy to our beaker of water, after 100 degrees Celsius we don't see any substantial increase in the temperature. Then where does this heat go? What do you think is happening? So this additional amount of heat energy supplied to the liquid is used in the phase change. So this heat energy is not used to increase the temperature, but this is used to change the phase from liquid to gas. So that is how this additional amount of heat is being utilized. So this heat is called as latent heat of vaporization. Before moving on to latent heat of vaporization, is this concept of boiling and boiling point clear to everyone? Yes?
Yes.
Okay, so let's move on. So as we have seen in our experiment, even though we continue to supply heat energy after 100 degrees Celsius, there is no increase in temperature. But this additional heat is used to change the phase from liquid to gas. So this amount of heat is called as the latent heat of vaporization. This latent heat of vaporization is represented using the letter capital L, and L equals Q by M. So now we can define latent heat of vaporization as the amount of heat or the heat energy which is required to change unit mass or 1 gram of liquid from liquid phase to gaseous phase is called as latent heat of vaporization. Let me write that down on the board. the heat energy required to change 1 gram mass of liquid from liquid phase to gaseous phase is called as latent heat of vaporization. And this happens at a constant temperature. Okay? This process happens at a constant temperature, and as we discussed, this constant temperature is nothing but the boiling point. So beyond boiling point, the phase change occurs, but there would be no increase or no change in the temperature of a substance. Any doubts up until this point?
No, madam.
Okay. Now, what could be the units for latent heat here? CGS unit for heat is, we all know the CGS unit for heat energy is calories. So Q is calories divided by mass. Again, CGS unit for mass is grams. So the units of latent heat in the CGS system is calorie per grams. And SI system. So again, the heat energy is measured in joules in SI system by mass. The units of mass in SI is kg. So joule per kg are the units of the latent heat. Clear? Okay. So for water, what do you think about boiling point of water? What could be the boiling point of water? We have discussed this even in our experiment, right? In the experiment, where does the temperature reading stop? At 100 degrees Celsius. Yes? Yes? So at this particular temperature, the water will start bubbling and we see vapor. Correct? So 100 degrees Celsius is the boiling point of water. That means once the temperature of the water reaches 100 degrees Celsius, then if we continue to supply heat, after that point the water will start to boil. Okay? So this is in Celsius scale. What could be boiling point in Kelvin scale? So remember, we have discussed in the in one of our previous sessions the conversion from Celsius scale to the Kelvin scale. Kelvin is equals to 273 plus Celsius. So in other words, 0 degrees Celsius in Kelvin is 273. So if it is 1 degree Celsius, we have to add 1. It is 274. Right? If it is 2, then it is 275 Kelvin. So if it is 100, then in Kelvin it would be 273 plus 100, 373 Kelvin. So the boiling point of water in Kelvin scale would be 373. So the boiling point of water in Kelvin scale is 373 Kelvin or 100 degrees Celsius. And what about latent heat of vaporization for water? So latent heat of vaporization for water is 540 calorie per gram. What does it mean? So when any water sample is at 100 degrees Celsius, then per 1 gram of the water, I need to supply 540 calories of heat in order for that 1 gram of water to convert into vapor. So that is what we mean by latent heat of vaporization. And the value for water is 540 calorie per gram. Any questions?
No.
Okay, we'll go ahead. Now that we understand what boiling is, what do you think is the difference between evaporation and boiling? Evaporation is also phase change from liquid to gas. And then we said boiling is also phase change from liquid to gas. But what is the difference? So when we are defining evaporation, we were very clear about temperature there, right? We precisely mentioned that evaporation can occur at any temperature. So it occurs at any temperature. And mainly this is due to the escaping of the water molecules from the surface. Evaporation is a surface phenomenon due to internal energy of the liquid particles. So it is a major difference here. Boiling is the process which occurs at constant temperature, and we define that constant temperature to be boiling point. So it occurs at a definite temperature which is called as boiling point. So evaporation and boiling are not same thing. This is the major difference between these two processes. Any questions up until this point? No. Can we move on? Okay, wonderful. So if we understand what boiling is, we can easily understand what melting is. So the exact reverse of boiling is melting. So again, let's do some simple experiment. Let's take a beaker. Now this time let's take ice cubes out of the fridge and let's put all the ice cubes in the beaker, and then we will start. Okay, we'll put all the ice cubes in the beaker taken out from the fridge, and then we'll start recording the temperature. Again, we'll take the readings, temperature readings for every 1 or 2 minutes. Now, mostly these ice cubes would be at a temperature of 0 degrees Celsius or slightly lesser. So, if the temperature of these ice cubes is less than 0 degrees Celsius, what happens over the time? The temperature starts rising, and once it reaches 0 degrees Celsius, now you won't see any change in temperature for a while. What happens once these reach 0 degrees Celsius? Slowly the ice cubes would start melting, right? You supply heat to it and take the recordings, of course. So now this heat supplied is utilized in not raising the temperature, not for the increase of the temperature, but this heat energy supply is being utilized to change the phase of water from ice, that is from solid to liquid. So additional heat whatever is provided at 0 degrees Celsius, these ice cubes will start turning into liquid. Similar to what boiling is. Okay, this is pretty much similar to what boiling is, but in boiling what happens, we are at 100 degrees Celsius and the phase change is from water to vapor, that is from liquid to gas. Now melting is nothing but the same thing, but here the phase change is from ice to water, that is from solid to liquid, and this is happening at 0 degrees Celsius. This happens at 0 degrees Celsius. So can I say then melting is the process wherein the phase change occurs from solid to liquid at a constant temperature again. Now what do you think this constant temperature is called as? This in case of water. What do you think this constant temperature is called as, wherein the phase change starts to happen from solid to liquid? It is called as melting point, right? When we were discussing about boiling, we called this constant temperature as boiling point, wherein water starts to boil. So now it is melting point. The constant temperature is called as melting point, wherein the ice starts to melt and the phase change starts to happen. Clear? Now the same way, when we are producing heat, right, this heat is used to change the phase of solid to water, right? So this is called as our latent heat. In this case, it is latent heat of fusion. This is called as latent heat of fusion. Clear?
Clear.
So boiling and melting are related to each other, but there is a difference in the phase changes for both. Any questions?
No, madam.
Okay. Now, melting point for water. Melting point of water. What is it? 0 degrees Celsius. At 0 degrees Celsius, the phase change happens. So, 0 degrees Celsius is the melting point of water. What this could be in Kelvin scale? 273 Kelvin. Okay. And latent heat of fusion for water. $80 calorie per gram is the latent heat of fusion for water. These are the values. Clear?
Clear.
Okay. Having said that, what could be freezing? Now, since we understood what boiling and melting are, it is easy to understand freezing, right? So freezing is the process wherein liquid phase, the phase change happens from liquid to solid. That means if we take the example of water, right? Water from liquid phase will turn into ice. So that is called as freezing. Even this happens at a constant temperature, which is 0 degrees Celsius. But in order for freezing to happen, heat energy should be taken out. If to the ice at 0 degrees Celsius, if we supply heat, it will change to water. Again, to water at 0 degrees Celsius, if we keep on removing heat, it will change into ice. So this process of removing heat and changing liquid phase to solid phase is called as freezing. Any questions?
No, madam.
Alright, now for water, when does this freezing occur? Again, it is 0 degrees Celsius is the freezing point for water. Alright, so any example of freezing? Yes, we observe this when we keep water or juices or liquids in our refrigerator, right? If we keep it in the deep refrigerator, they will change their phase into solid after a while. And also during winters, our coconut oil or ghee kept, right? They would be also converted into solid phase. So that is the freezing. When heat is taken out, then the phase change occurs from liquid to solid is your freezing. Any questions?
No, madam.
Okay, that brings us to the end of this chapter. So in this chapter, we have learned about lot of interesting things like heat, temperature, kinetic energy, relationship between kinetic energy and temperature, specific heat, how to determine the specific heat, principle of method of mixtures, and we talked about evaporation, condensation, boiling, melting and freezing. Alright, so that is end of this chapter, heat. I hope you enjoyed the session. Thank you.